So in chapter 8.3, we're going to calculate confidence intervals for a population proportion, P. So our objectives in this chapter is construct a confidence interval for a population proportion, find the sample size necessary to obtain a confidence interval for a given width, and the final thing that I didn't put down is that we're going to look at how to calculate confidence interval using the TI-83 or 84. Our first objective is to construct a confidence interval for a population proportion. So our first problem that we're going to look at is the music organization Little Kids Rock surveyed 517 music teachers. 403 of them said that video games like Guitar Hero and Rock Band, in which players try to play music in time with a video image, have a positive effect on music education. Assuming these teachers to be a random sample of U.S. music teachers, we would like to construct a confidence interval for the proportion of music teachers who believe that the music video games have a positive effect on music classrooms. So there are some notational ideas in this chapter that we need to know about. P is the population proportion of individuals in a specified category or having a particular characteristic. X is the number of individuals in the sample who are in the specified category or who have the characteristic. N is the sample size, and P hat is the population of individuals who are specified in the category. P hat is defined to be P hat is equal to X over N. So in this particular chapter, we're moving from a binomial scenario. So if we start out with our population, we either have two situations, two outcomes. It either has the characteristic, yes, or it does not have the characteristic, no. So here's our population. It's a binomial. And this is P of success, and this is 1 minus P of not success. So now we don't know what P is. We're going to estimate P from our sampling distribution of P hat. So P hat we know is normally distributed. P is right here. And so the idea is from the sampling distribution, we should be able to find a lower bound and an upper bound to estimate our p-value, our proportion of folks that have the particular characteristic. So to construct a confidence interval, we need a point estimate. The point estimate for the population proportion P is P hat, which is X over N. X equals the number of individuals who have the characteristic. N is the sample size. We also need a standard error of P hat. By the central limit theorem for proportions, we have that the standard error of P hat is the square root of P hat 1 minus P hat divided by N. To compute the margin of error, we multiply the standard error by the critical value Z. So the margin of error is equal to Z times the square root of P hat 1 minus P hat divided by N. So our confidence interval is the point estimate plus or minus the margin of error. And so we have P hat plus or minus z times the square root of p hat 1 minus p hat divided by n. So we have a lower bound. Here's our lower bound where we minus the margin of error for p, and now we also have an upper bound on our confidence interval. The method for constructing a confidence interval for a population proportion requires that the sampling distribution be approximately normal. The following assumptions ensure this. We have a simple random sample. The population is at least 20 times as large as the sample. The items in the population are divided into two categories. They either are successful, P successful, or 1 minus P scenario. And the sample must contain at least 10 individuals in each category. This means that n times P has to be greater than 10, and n 1 minus P has to be greater than 10. So in our survey of 517 music teachers, 403 said that the video game Guitar Hero and Rock Band have a positive effect on music education. We want to construct a 95% confidence interval for the proportion of music teachers who believe that the video games have a positive effect. So in this case, we will first begin by checking the assumptions. We have a simple random sample. It is reasonable to believe that the population of music teachers is at least 20 times as large as the sample of 517. The number of items in the population can be divided into two categories. There are 403 teachers who have the characteristic that they believe the game have a positive effect on students, and there are 414 who do not believe that they have a positive effect on music instruction. So there are 10 or more items in each category. The assumptions are met. So when we said that n times p has to be greater than 10, what we're actually saying is that n in this case is a sample size, and if we multiply p, actually p hat, which is 403 divided by 517, we will see that the 517s cancel out, and that indeed there are 403 teachers who believe the game have a positive effect, which is greater than 10. So p hat in this particular case is 403 divided by 517, which is approximately equal to 0.779. The next part of the solution is to find the critical value. So we need to go to table A3 in the back of the book, and at the very bottom of the table we can see what the critical values are for Z at a 95% confidence interval, and we see it to be 1.96. So the margin of error is Z, the critical value, times the standard error, which is the square root of p hat 1 minus p hat divided by n. In this particular case, this was wrong here. This should be 0.779, 1 minus that. And when we do the calculation, we get a margin of error of plus or minus 0.035738. So the 95% confidence interval is our point estimate, which is 0.779497 plus or minus the margin of error. And we get a lower bound if we round up to 3 decimal places, to 0.744 to an upper bound of 0.815. So we're 95% confident that the proportion of music teachers who believe that the video games have a positive effect on students for music is between 0.744 and 0.815. Our second objective is to construct a confidence interval for a population proportion using a TI-83 or 84. Again, we're going to use the same problem that we used in the previous case, where we have the music organization Little Kids Rock surveying 517 music teachers, and 403 of them said that the video game, like Guitar Hero and Rock Band, in which 442 players try to play the music in time with a video image, have a positive effect on education. We assume these teachers to be random sample of U.S. teachers. We would like to construct a confidence interval for a proportion of music teachers who believe the video game have a positive effect on music classrooms. So in this case, when we go to our TI-83 or 84, we'll hit our stats key and we'll move the cursor over to test. Once we get to test, we'll move down with our cursor until we get to option A, which is 1 proportion z interval. We will enter then, when we hit enter, we will enter the values x, n, and the confidence level, and then hit calculate. So again, with this particular problem that we had before, we go through the same process of finding the assumptions, and we found that the assumptions were true for the survey of 517 music teachers in understanding whether or not the video games have a positive effect on music education. Now we'll use our calculator. We press the stats key and highlights the tests menu, and we select the 1 proportion z interval. We enter 403 in the x variable field for our menu, and then we hit 517, which is our sample size for n, and then in the confidence level, the C level, we hit 0.95. Then we select calculate. Our screen comes up with the confidence interval. The lower bound is 0.74376, and the upper bound is 0.81523, and you will notice that when we round it up, we get a confidence interval about the same as when we did it by hand, 74.4% to 81.5%. Our second objective is to find the sample size necessary to obtain a confidence interval of a given width. For this, we're going to use the idea that m is equal to z times the square root of p hat 1 minus p hat divided by n. So our idea to find a sample size is we have to solve this for n. So what do? Is we square both sides of the equation. When we square both sides of the equation, we get m squared is equal to z squared times p hat 1 minus p hat all over n. Now we have to isolate n, so we multiply both sides by n and we divide by m squared. And now we get n is equal to z squared p hat 1 minus p hat all divided by m squared. So that's the equation we're going to use to find sample size. So we're going to reiterate what we just did. If we wish to make the margin of error of a confidence interval smaller while keeping the confidence level the same, we can do this by making the sample size larger. Let m represent the margin of error. Of course, m equals z times the square root of p hat 1 minus p hat divided by n. By rewriting the formula using algebra and solving for n, we have n is equal to p hat 1 minus p hat and then the square of z over m. So here is our formula. This is the minimum sample size needed to obtain a margin of error of size m. If the value of n is not a whole number, we round up to the nearest whole number. In order to use this formula, we need a value for m and p hat. We can set the value of m, but we don't really know ahead of time what p hat is going to be. There are two ways to determine a value for p hat. One way is to use the value that is available from a previous drawn sample. The second is if we don't have any samples at all, we assume that p hat is 0.5, which makes the margin of error as large as possible for any sample size. In this case, the formula simplifies to 0.25 with the squared ratio of z over m. So in a survey of 517 music teachers, 403 said that the video game Guitar Hero and Rock Band have a positive effect on music education. Estimate the sample size needed so that 95% confidence interval will have a margin of error of 3%. So here we're determining what the margin of error is going to be. From the bottom row of A3, or by technology, we see that the critical value of a 95% confidence interval is 1.96. This is a number we probably want to memorize. We compute p hat to be 403 divided by 517. This is equal to 0.779497, and our desired margin of error is 3%. So the sample size necessary, we use the formula n is equal to p hat times 1 minus p hat times the square of z over m. When we plug the numbers in to our calculation, we get a value of 733.67. Here we want to round up to 734. We plan to sample music teachers in order to construct a 95% confidence interval for proportions who believe that listening to hip-hop music has a positive effect on music education. Here, we have no value of p hat available. We estimate the sample size needed so that 95% confidence interval will have a margin of error of 3%. Well, because we cannot find a previous sample so that we can find a p hat, we now have to estimate what p hat will be. And so our solution is, again, our critical value for 95% is 1.96. And since we don't have an estimate of p hat, we use the formula n is equal to 0.25 times the squared ratio of z over m. Notice in this case, we estimated this case that p hat is 0.5, and so when we plug it into the original formula, we get 0.25 for p hat times 1 minus p hat. Since now the desired margin of error is 3%, when we do the actual calculation, we plug all the information in for z and the margin of error, and we get our sample size to be 1067.1, and again we're always going to round up, and in this case we round up to 1068. So in both of these cases we are able to find the sample size necessary to conduct the study. So in this section we want to know how to construct and interpret a confidence interval for the population proportion P, how to find the sample size necessary to obtain a confidence interval for a population proportion given the width where the estimate of p hat exists and where no estimate of p hat exists. So that concludes our chapter 8.3 and also on estimation in chapter 8.